Okay, let's take a look at how to write a formula, a chemical formula, if I am given the types of ions that make it up. First of all, so I have these two examples here. When we talk about ionic compounds, it will always be made up of a metal and a nonmetal. The metal is always listed first, and the nonmetal follows. The ions or the ionic compounds are typically not charged, which means that we have to make sure that we write the compound in such a way that all the charges, the positive charge has to equal the negative charge total. So let's take a look here. I have oxygen and I have sodium. Now we mentioned in lecture that sodium is group 1, and therefore all group 1 ions will always form a +1. So if you know group 1 forms a +1 ion, group 2 forms a 2+ ion, group 3 forms a 3+. And then when we get to group 5, they form a -3. Group 6, which oxygen is group 6, is a 2-. Group 7, which is halogens, chlorine, bromine, iodine, etc., they have a -1 charge. Okay? That just tells you how many electrons they lose or gain to get to that 8th group, the group of noble gases. So I know that my oxygen is a 2- and my sodium is a +1. Sodium is a group 1, has a +1 charge. Oxygen is a group 6, has a 2- charge. So let me write this compound, and like I said, we're going to have to write the metal first because that's convention. So metal is written first and then the nonmetal. Okay, however, I have a 2- charge here and a +1 charge here. Therefore, this is not a neutral compound the way it's written because I have an excess negative charge. To make this the same, or to make the charges cancel each other, the positive and the negative charges, I need an extra sodium ion, an extra +1 to make it a +2. +2 - 2 gives me 0. An easy way to remember it is to take the charge of one of the ions and cross it down, put it down as a subscript by the opposite ion, and take the charge on the other ion and cross it over and write it down as a subscript for this ion, even though if it's 1, we don't write it. So this would be sodium, and we said we take that charge from the oxygen and bring it down as a subscript on my sodium ion here. So that makes 2 sodiums, and then I write the oxygen. That +1 of the sodium will come down here. It would be 1 like this, but we don't typically write the 1. And so this is my formula, Na2O. Once again, let's double check. This has a 2- charge. Each sodium has a +1, but I have 2 of them. So 2 times +1 gives me a total of +2. -2 gives me 0. So this is a neutral compound. This is how we can go and we can write the correct formulas for ionic compounds when we know the charges of the ions. Let's look over here. I have a 2+ and a 3-. Now beryllium is my metal, so it's going to be written first. So let's write beryllium, and then let's write nitrogen. Nitrogen has a 3-, beryllium has a 2+. If we follow this method, we can take the charge of the nitrogen and bring it down as a subscript for beryllium. We can take the charge on beryllium and bring it down, cross over, by the nitrogen. Therefore, beryllium will have, I need 3 berylliums to manage or to cancel out the 2 nitrogens. Now let's look at and see what my total charges are. We said sodium or nitrogens have 3-. Berylliums, each of them will have a 2+ charge. So 3 berylliums times 2 gives me a total of +6. Let's do this one. 2 nitrogens, 3- each, gives me a -6 charge. So if I add these together, I get a 0 total charge. And that tells me that I have written this formula correctly. Okay, I will do a couple more examples and then we will move on to naming.